Phase 1, we want to look at the limit as x approaches infinity and as x approaches negative infinity for these rational functions. And the trick that we're going to use, and you might develop some shortcuts, feel free to use them. But the trick we're going to use is to look at the highest powered x in the denominator and divide everybody by that highest powered x. Even if there's a coefficient on the term itself, like even if this had, like, say, a 7 in front of it, you'd still just divide by the x. You wouldn't worry about the coefficient whatsoever. And as I look at this particular function, the highest powered x in the denominator is just x to the first power. So as I divide each piece of this by x, x divided by x is 1. This guy divided by x is 1 over x. This x divided by x is 1 again, and then 5 divided by x is negative 5 over x. And then the whole point is that we're imagining what happens as x gets really large, as x goes toward infinity. And what happens is this is not affected at all. This is going to stay 1. But as x gets really ginormous, this part gets really tiny and basically approaches 0. As x gets ginormous, this 1 is not affected by x at all. And then this is also going to go towards 0. So at the end of the day, or at least this problem, I'm going to have this equals 1 minus 0 over 1 minus 0, which is 1, which is 1. And if I were to go through and find the limit as x goes to negative infinity, none of these steps would really change. This would still go to 0, this would still go to 0, these would still go to 1, and so that limit's also going to be equal to 1. And if I wanted to be super precise or super organized, I might summarize those two thoughts with these statements. And again, one of my targets for you guys today is to look at an expression like this and not have it make your brain melt, but have you recognize that we're basically just saying this part of the function right here just tells me that x is getting really large. And what I'm learning is that as x gets really large, the y value gets close to 1. As x gets very negative, the y value gets close to 1. The second part, where we look at the table for undefined values, I'm going to do in a separate video. So let's do it.